Okay. Hello,
But
everyone. This is Leader Associate Impact. I'm Cheryl, Research and Content Analyst, and welcome to our show. Well, the figure of 100 gigawatts by 2045 is exciting for the Vietnam wind market, and more importantly, the Vietnam offshore wind market is also becoming active, with many domestic and international developers looking to make a splash here. Today, we invite Mr. Riccardo Felici, country lead, OWC Vietnam, to give us a brief introduction to offshore wind in Vietnam, from concept to operations. Well, Mr. Riccardo, please introduce yourself briefly and then start your presentation.
Hi, Joe. Thank you. I'm Riccardo. I'm OWC country manager for Vietnam. OWC, it's an energy company supporting developers throughout their different stages of development here in Vietnam, from early concept designs all the way through to construction supervision and operation and maintenance supervision. I will introduce a bit more about OWC in a minute. Myself personally, I'm a project manager and naval architect as background. I have over 7 years experience in offshore wind installation and transportation, specifically relating to cable and foundations. For the past year and a half, I've been focusing on Vietnam, supporting OWC Group into the development of different projects in the country. Let me share a screen and we can get started. Let me know if you can see the screen.
Yes, I can see that.
Now? Hi, Charles. Yeah, as mentioned, I represent OWC, which is an international company supporting developers throughout their project life cycle assessments. So from really early on, in terms of deciding how to enter the market, all the way through to construction supervision and operation and maintenance support supervision. For those of you who don't know OWC, we are part of the wider ABL group, which is also another international group supporting the wider energy and maritime sectors. OWC was established in 2011 by a team of experts who was involved in the early development of offshore wind since the 1990s. We, to date, have consulted over 68 gigawatts of projects and in over 82 different projects since 2011. And this has been on several different countries, several different market entry and market stages of those countries. We are the global specialist, especially in regards to offshore wind, and we have experienced technical advisors in engineering and project management, as well as all the different specialities needed in the wind farm sectors. We have to date over 100 specialists in offshore wind development, and these are deployed in over 8 countries. We proud ourselves to be an international company with local support and local understanding. That means for us to be present in every country where there is major developments. And with regards to specifically Asia Pacific, we are based in Taipei since about 2018, when the market started to grow. We're then based in Korea, Japan, and Vietnam, where I'm speaking from. To date, in Vietnam specifically, we worked on over 25 projects. So this was from the really early nearshore projects all the way supporting to offshore wind projects to date, and other clients and developers entering the market as we speak. As I said, we offer different services, different stages of the supply chain and of the project life cycle. So supporting offshore wind developers on development of their projects from the moment they have 4 corners around their map, with engineering, commercial, technical, and project management assessments, both from really early studies, so looking at design envelopes, all the way through to concept designs, pre-feed support, and then we're able also to run the ITTs and manage those ITTs for the different developers, helping them select the correct and the most suitable local EPCI, as well as them managing the EPCI through the construction process. We're also able to offer supply chain and other kind of financial and investor studies, which are really early on in early markets, supporting entry strategies and market assessment, as well as technology studies for the different areas of different projects. To name a few, we are, for example, the leading expert in floating wind, having worked on all the major projects to date regarding floating wind development to industrial scale. As I said, we're based worldwide, and I think specifically to Asia Pacific, we are really in the main locations for offshore wind. Most recent ones developing more into Australia, where we're also starting to grow our team in the country. So today the presentation is to look at the offshore wind life cycle assessment and going through the main steps typically involved in an offshore wind farm development. So I think the most simplistic way to look at it, and I think this is always the kind of the first step that most people think of, is of course for a wind farm we only need kind of the wind resource. We'll need wind turbines, and then all of a sudden we just get electricity wherever we need it. This may be kind of a typical assumption based on thermal power plants that can be located in locations near the demand centers and can provide kind of a more simplified approach. However, when we start to see the involvement of renewable energy and the need for different steps, you'll see that the picture gets a bit more complex. So what is the typical life cycle of a wind farm, you may ask? So starting from a first assessment, you start to see that we can't control the location of the resource. So we are not able to ship, let's say, or to condense the wind in one area and then move it to another area for extraction near demand centers. But instead, if we take the example of Vietnam, we can see that there is really high wind resources in the kind of the southern part, with demand centers instead spread along the coastline. So what we need to do is essentially move this resource, extract the resource in terms of electricity or hydrogen, whichever we're looking at, and be able to move this energy now to the demand centers. The way it's done, of course, is that we'll need to have a grid, and we can't, and this grid will have to be dispatched from central substation areas. And these are, for example, shown here in the map as the red dots. So the first assessment that we need to do is to understand where is our resource and where are our demand centers, and really answer the question, how do I connect the two in between, and how can I move power from one side to my demand center. In this case here, we show that also the other assessment that we need to do is that there's always multiple options. So we can't often take a simplistic assumption that all the power goes to a single location or to a single demand center at least. So we need to assess and evaluate which is the best kind of exporting option and where do we bring that power to. If we think of a regional view, then this problem gets even more complicated because if we think of, let's say, different demand centers, for example, shown here in the dots, presented in Singapore, Malaysia, Brunei, and Philippines, there may be demand centers there, and we may have resources, for example, in Vietnam in terms of wind resources. However, to connect these kind of locations, we then need kind of additional infrastructure, additional kind of expenditures on these areas. So after we understand kind of the global picture of where my resources are and where my demand center are and how can I start to connect these two, we need to, of course, start to really understand better the site specifically. So assuming that we have selected a single site, where we think the resources are good and they are near enough to my demand centers where I can try to figure out the connection to get the power there. We need to start to assess these resources. This is done for typically kind of a wind assessment and kind of a seabed survey. Initially, we will do a typical desktop review study that will look at the resources at the high level based on publicly available data. And we're then able to assess and decide, okay, what kind of surveys and what kind of analysis do I need to do to be able to understand my site and to understand the wind assessment over the lifetime of the wind farm. So in this case, we would typically then carry out a strategy assignment to look at the wind through what's called typically a FLIDAR or a fixed LiDAR, which uses lasers to calculate the wind speed at different turbine height for a period of at least 1 year. And then we'll also look at the on the seabed side, what kind of surveys are needed in terms of side scan sonar, multi-beam, core samples of the site. And really what both these assessments do, they start to give us a really detailed understanding of our site. Once we start to understand our site in terms of environment and in terms of resources, of course, we then need to start to think, okay, so what kind of turbines do I need? And what kind of foundations do I need? How do I connect these? So what we would do was typically kind of design and equipment selection. Of course, wind farms that are located offshore, they may need a offshore substation. This is dependent on the distance to the shore and to the distance to the onshore connection point. What's shown here on the left is a typical kind of a simplified diagram, for offshore wind connections, where you have to imagine that for each of the turbines you're going to install, you're going to have to look at the cabling solution to connect those turbines to a substation, and then to connect the substation offshore to your substation onshore. Other assessments that are typically of course needed is to look at the turbine selection. So to select the most suitable turbine for your site to be able to extract the most amount of power. And then looking at the electric architecture. So what is my most suitable architecture such to reduce the cost? And we then need to look at the cable routing as well, because not always the straightest line is the most feasible line. There may be instances where there is wrecks or other kind of both human or natural activities that may lead to a cable route export option be much longer and needing to route around certain obstacles. This would form a sort of initial design and equipment selection. Another important area to look at during your early stage design is to look at the supply chain. So once we start to understand what kind of equipment do we need and what kind of foundations and cables and electric architecture we're going to have, then we need to start to think, okay, how is it going to be built in Vietnam or in a specific country or specific site? Of course, the supply chains nowadays are global, so different parts are being built in different countries, and this will need a careful assessment. Not everything will be able to be built in Vietnam, but we may consider that different components are built in places. In the example shown here, we're showing different kind of vessels navigating towards Taiwan. Towards Vietnam. For example, we could consider a blade factory in Taiwan, nacelle components being shipped from Europe, as well as maybe some parts, some transition pieces being shipped from other parts like Korea or Indonesia or Malaysia towards Singapore. An assessment of this supply chain is critical at the early stages because it has quite a large impact on your LCOE. And ultimately, it's important to start the conversations with the different kind of suppliers and different authorities to understand, what are the requirements for that supply chain. Finally, one area which is not quite clearly shown in the slide, but is to look at the port infrastructure for your project. So understanding that all these components will need to come from different places. Some of them will come from Vietnam. but all of them will have to be in a central port near your site to be able to be installed relatively quickly. So this will need an assessment of your port facilities, both in terms of manufacturing, what can be done locally, but also in terms of what can be stored locally ahead of installation on your project. Once we have an assessment of our ports and we progress our design to a level that we're satisfied with, of course we can then engage our EPCI, which will start the construction itself of the wind farm after detailed design. And here I just wanted to kind of highlight maybe the main steps that we would typically see on a wind farm. First step, looking at the kind of onshore and seabed preparation. So of course we'll have a lot of onshore works looking at the onshore substation, the connection to the grid or to the onshore substation that is present, all the way to the beach, where we'll need to either have an open cut trench or have a HDD running to the sea. And all these works will require a lot of preparation, as well as works which are offshore, such as seabed preparation. So in areas where we have large sand dunes, we may need to excavate part of these sand dunes ahead of the cable laying operations. After these preliminary operations, we can start with the foundation installation, showing here in the top right for typical jackets, for which we'll need really specialized vessels, and for which we'll have we'll need to have our seabed pre-prepared. These installations can be done by several different methods, depending on the foundation type that is being selected for the project. Once the foundation is in place, we look at our nacelle installation, as well as blade installation after that. Again, all these foundation, nacelle, and blades installation, as well as the ones covered in the next kind of points, are all done by specialized vessels. Now, this, of course, it's important to also have an assessment of at early stage of design to understand the bottlenecks of the project and the criticalities that may ultimately lead to a higher LCOE due to lack of availability of certain vessels. After the turbines have been installed and we have already our foundations, we can start with the installation of your offshore substation, shown here on the top left. And this can be done as a kind of one piece, or there's different solutions for the offshore substation as well, installation. But again, you'll likely need a kind of heavy lift vessel or a largely specialized vessel for this operation. And finally, looking at installing the cables, which are what transfers ultimately the energy produced by the different turbines. And the cables were typically separated between inter-array, so between the different turbines, and export cables connecting the offshore substation all the way to the shore. And then finally, onshore cables connecting kind of the last mile up to the connection point. Finally, assuming all goes well and the wind farm is operating, we start to run into what's called operation and maintenance. And here we look at several different operations. Typically, these are kind of dictated by your specific design, or I should say that the frequency of these operations is dictated by the specific design. Most obvious is the maintenance operations on tower, nacelle, and blades, which may undergo fatigue or may need kind of adjustments throughout their lifetime. But of course, we also focus on other areas which may start to show signs of failure, such as cables, which do happen to fail, for which we'll then need to run kind of operation for repairing these cables and reinstalling new cables, or just adjusting the broken section, replacing the broken section. Sorry. Finally, there's also kind of looking at the turbine in case of extreme failure, or in case of areas where maintenance is not sufficient. We may be looking at main component upgrade, replacement completely. So this will involve, again, having specialized vessels on site to be able to remove the large components and reinstall them, reinstall new ones. Finally, probably the last step of the life cycle assessment is looking at the decommissioning of these offshore wind farms. This has kind of been done on a few projects to date, but really it involves removing all the turbine structures, removing the foundations up to seabed level. So this shown at the bottom right here will involve kind of plasma cutting of the pile. Or other solutions to be able to remove the pile from the ground. Then finally, of course, we need to decommission also the substation and all the cabling connecting in between. So these will have to be removed for most of these sites. And where possible, we'll need to look at reusing, recycling before disposing completely of these components. Now, just to run kind of a simple conclusion, I think, so from what we said at the beginning, it's not just looking at kind of a wind resource and then just thinking of just a few turbines installed in the sea. We can see that the picture it's much more complex. We need to look at the wind assessments, understanding our resources, so on the wind side, and also understanding our site in terms of the survey of the site itself. We then need to select the right equipment and the right kind of architecture, overall philosophy of the wind farm. We look at port and infrastructure in the very early stages before even starting to consider the actual design, finalized design. Once we have kind of a finalized design, we need to look at transportation of these components to site and where are these going to be stored temporarily before installation. And during installation and commissioning, we've seen some of the main challenges in terms of having specialized vessels and the different aspects and different areas that need to be installed for a wind farm. And finally, we need to look at operation and maintenance of the wind farm, as well as decommissioning at the end of life. So just to kind of finish off, how can we help? Really is that we can help from day one, from the moment the developer is starting to think about a new market, to think how to enter the new market. We can help on market entry and strategies, understanding the CapEx and DevEx development costs, as well as defining the concept of the wind farm in more details. Carrying out survey, we can help specify and supervise the survey campaigns, as well as wind measurement and Metosha measurement campaigns. Cheryl, I'm happy to have any questions from your side, but otherwise, for all those of you listening in, just feel free to drop me or OWC colleagues an email for any questions you may have.
Well, okay, thank you, Mr. Riccardo. There is indeed a lot of practical information that we would like to know, but not only the project itself and the external environment and the market situation are important before we decided to commit to offshore wind. So let's move on to our Q&A session. Are you ready for that?
Sure.
Okay. Then, Mr. Riccardo, my first question is about the policy regulation. We all know that the policy mechanism in Vietnam is still in a state of uncertainty. Well, DPD8, we still don't know when we will have the official one. So do you think this will bring any risk to our project planning?
Yeah, I mean, in fact, I mean, we can see already the impact in the market. I mean, offshore wind projects are needed in the grid to reach the net zero goals that were set by Vietnam. Projects take at least kind of 7 years or more to reach the COD. So it's not just about projects, but it's also about having an efficient consenting mechanism. Grid and infrastructure need to be developed to enable these projects. So really, certainly it's required that the government and is setting clear rules for investors to proceed ahead essentially with the studies. At the moment, we are seeing essentially that there is a bit of a standstill in the market where developers are hesitant um, to develop their sites because, of course, the conditions are unclear. And therefore, this hesitation leads to the critical studies not being done at this stage, which then will likely lead to a delay of the delivery COD of after 2030. So to answer your question, yes, we can see that there is certainly risks, and we can see that there is impact on the market from this uncertainty in policy.
Okay, thank you for that. And the second question is about the grid issue. The renewable energy suffers a lot these days because of the grid and infrastructure issue. We even heard from data or news from the solar energy that there's maybe only 30%, 40% of the production volume can be reached. So this means we may have a lot of curtailment for offshore wind. The volume of a project is always much larger than the onshore ones. So is it possible that the curtailment will be more serious in offshore wind projects? And is there any considerations in the field of power cells?
It's an interesting point you raise, but really, when the moment we're talking about a new technology, so when there's also a kind of a wider considerations to be had. So when there is a decision to increase renewable energy project as a whole in the National Power Development Plan, we're also looking at an overall picture of the grid and upgrading that grid such to be able to withstand new projects and to be able to withstand the new mix of energy within that grid. And this is not just national grid, but also kind of regional grids, looking at more in detail kind of the storage and frequency reserves, as well as dispatch control facilities and other policies that go together with looking at renewable energy as a whole. So what I would say is that, of course, if we consider the current grid, and we were all of a sudden to add kind of 8 gigawatts of offshore wind, this would lead to really a high increase of curtailment. But this is not the case, and this is not what's happening in Vietnam. Of course, at the same time as we're discussing renewable energy and renewable energy development, there's also discussions on how to improve the grid and how to better that and modify that such to be able to take in more renewable energy. Of course, grid development will take time to be implemented. And so it's even more critical, going back to your first question, to have that certainty on the investment rules and on the development rules, such that we can start to develop renewable energy as a whole in Vietnam. There is also kind of many different lessons that we can learn in terms of curtailment from different countries that are also coping with the high level of renewable energy, and that could really help Vietnam.
Okay, thank you for that. And can you introduce us exactly the situation about the LCOE of offshore wind in Vietnam? Because I think many players that care about the construction cost, turbine, and the maintenance, and these things make them worried about the LCOE of offshore wind may be too expensive for them.
Yeah. I can see that, and I think interestingly, several studies are being done as we speak on looking at Vietnam, looking at the existing supply chain, and especially ways to repurpose that those existing ports and infrastructure that were used to support oil and gas to essentially repurpose them to look at renewable energy. So there is studies with regards to the aspects and being done to effectively look at the impact on the LCOE. Because in fact, when we look at in an emerging market where a new technology is being introduced, LCOE can be actually very susceptible to cost needed to develop this supply chain. Now, in every country, we've seen that kind of in every other emerging market, like we could say kind of Taiwan, Korea and Japan, a kind of similar early stage. We've seen that with the right incentives for the first rounds of projects and a clear long-term policy of the country, the LCOE can actually reach really competitive values, and this has been proven over and over. So ultimately, the LCOE doesn't depend only on the global technology cost reduction, but also really on the government policy and the initial incentives and initial kind of vision set out by the government as well. So I think what would be critical is that delivery of the first projects will really demonstrate that the risks the developers are expected to take can be manageable, and this will provide confidence overall into the investment into a single country, and ultimately that growth of an industry will ultimately reduce the LCOE cost.
Thank you. You mentioned the supply chain parts. The global supply chain has actually been hit rather hard this year, I think, with the shortage of raw materials, the price increases, and longer transport cycles. So, do you have any views on procurement and supply stability? What we can do to avoid this kind of risks?
I mean, it's a difficult question. I think if one had the answer, it would be kind of it would be only probably unique in the world to have that answer. We know that we live in a really really diverse market, which with many actions which are kind of unrelated to the single market, but it's kind of on a global supply chain, which affect the specific technologies. To make an example, you know, if we think of the war in Ukraine, it's now affecting kind of supply prices all over the world. So it's difficult to predict that and to have kind of countermeasures in place to be able to cope with that, or at least to manage that risk completely. But what we can look at is, of course, having part of the supply chain near the project for the major equipment, such as foundation, substation, and potential cabling, to have at least an understanding of where this supply chain is and what is the capacity of that supply chain. But to take a look at and kind of on the regional, if not global market, because of course if we just zoom in onto Vietnam, it's quite a well-placed market. Looking at it already has some of the foundation supply chain. However, when we look at it on the regional level, some of the components like cables and potential kind of turbines are also being shared on just a few locations with the whole region. So it can really stress the supply chain quite quickly. So I think to answer your question, it's difficult to put something into place to manage that risk, at least completely. But we can look at reduce that risk.
Oh, thank you. Well, we are now in a global world now, so we have many international players in our Vietnam market. Where has there been any difference, and what are the challenges for these foreign investments?
So the foreign investments are looking into a new market with the new technology. So there are things to consider in terms of having a good and in-depth understanding about your site and about your supply chain, like you mentioned. We need to really... Sorry, you were saying something?
No.
Oh, sorry, I heard something. Never mind. So we need to take an in-depth assessment of the market in terms of its supply chain and port and infrastructure, like we mentioned, and for investors to have that the added kind of comfort They need to have a clear understanding from the government in terms of policies, and also a clear commitment from the government looking ahead 15, 20 years and longer into the future. So we need to be able to give to investors a picture of growth where there could be several different projects developed in the next years. With an increase demand, then will come kind of a supply chain, and that will be able to be supported by different ports. But if we don't start with that clear picture in terms of investment and look ahead in the future, then this will harm ultimately the development of this new technology in Vietnam.
Well, and in the end, as a growth expectation one, how many megawatts do you think in the Vietnam offshore wind it will reach by 2030 and 2050?
I'd like not to answer in the sense of, I think there's been too much focus on megawatts as an indicator of success for the policy. So many people have been really kind of focusing on the number as if we were to say that, you know, if we're saying 50 gigawatts by 2030, it's an achievement. But really, what's critical is that it's really important to show a commitment from the country to a long-term view, like I just said. So it's good to see kind of megawatts in terms of an indicator of that commitment. But really what's more important is to get the right economical framework, especially on the revenue side. So we're talking, you know, is it FIT, auction, what kind of rules are for the auction, as well as the policy framework and investment guidelines that the industry can grow organically in these first projects. So really, if we're able to set, even on a small number of megawatts, the right steps for the industry, showing kind of the right economical framework, policy and investment, as I said, then really this will set the foundations right on which we can build a much larger industry in the future. Ironically, I think that a high number of megawatts in the short term, say by 2030, can actually be a big threat for the net zero goal of Vietnam, because either it would lead to a failure of not being able to achieve that goal, that number of megawatts, because, you know, it may be over ambitious, and that will lead to kind of less kind of interest from investors or less confidence from the investors. Or if we are able to achieve it by using kind of external supply chains away from Vietnam, then ultimately this may also lead to a higher LCOE. So both of these outlook for really high megawatts numbers for Vietnam by 2030 are not really optimistic. And really what I think as I said, what I think is critical is to have maybe a lower number of megawatts, but looking at having the right steps to get to that number and be able to create the foundations for an industry in the years to come.
Well, thank you for the generous answer and also for your informative presentation. I really learned a lot from today's sharing, and thank you for taking your time. I hope we have the opportunity to work together in the future sometime. Please follow our Leader Associate Impact series to get more content about the green industry around the world. See you next time. Bye-bye.